Okay, hey guys. Today we'll be doing the first prac we did this term, the bromine water prac. That's where we try to differentiate between hexane and hexene using bromine water. Okay, so before we jump into the prac, there's a few concepts we have to know, or a couple. These two reactions, addition reactions, addition reactions and substitution reactions. Now, alkenes use addition reactions, they undergo addition reactions, and alkanes undergo substitution reactions. So we'll do alkenes first, shall we? Okay. Now, addition reactions are pretty simple and really straightforward. All you do is you add. So in say this case we're using bromine, so we're using bromine water, which is Br2. So whenever you're adding something to an alkene, so in this case Br2, all you have to do, it says in the name, is you add. Now where do we add them, right? Well, this double carbon bond here is what makes alkenes alkenes, okay? And it's because of this that we can add these bromines on so easily. Now why is that? Well, you might think that a double bond, this double bond, is stronger than a carbon bond, and this double bond is stronger than a single bond, right? Most cases it is, but in carbon chemistry it's not. This double bond actually makes this whole molecule a lot more reactive. It's actually a lot easier to break. And so these bromines can just add on there without any need for outside energy, outside interference. So this reaction actually happens pretty fast and on its own. So what basically happens, this double bond here breaks, is eliminated, and you have two new bonding sites. One on this carbon, so it has 4, and one on this carbon. And all these bromines do, as it says in the name, is they add on. Like that. That's it. Ta-da. That's all an addition reaction is. It needs no outside energy. It just breaks that weak double bond with the carbon there, and it's fast. That's it. Now in terms of substitution reactions, only alkanes undergo substitution reactions. So we use bromine again, because we used it in the last one, and it's what we did in class. So when we can't just add these on, we can't just break a double bond and add them on, like we did here, because there's no double bond in an alkane, right? All there is these hydrocarbon bonds that we have to break. Now these ones are a lot stronger than that double carbon bond we had in the alkene. They are a lot stronger. So these bromines can't actually break them by themselves. To do that, they need outside help, which comes in the form of UV rays. These UV rays add energy to the particle and basically allow these bromines to rip off some hydrogens, and we can substitute these hydrogens with the bromines. So what happens basically, the two of these hydrogens are eliminated. Now it could be any two, really. It's random. It could be any two. It could be this one and this one over here. It could be this one and this one. It doesn't really matter. So those two are eliminated, and the bromines literally substitute themselves in. Like that. It's pretty simple. The only extra thing is, those hydrogens that were eliminated after the reaction, they form their own gas. They form H2 gas, right? That's basically an alkane reaction. It requires outside energy to break the bonds to allow the bromines to substitute themselves in, right? And because it needs outside energy, it's a relatively slow reaction as well, okay? And you have to break these bonds with quite a bit of UV energy, and light doesn't provide that much energy, so it takes time. So, now that we understand that, basically, we can jump into the prac. So the prac was, if I'll say it again, differentiating between hexene and hexane, or really differentiating between an alkane and an alkene. But in class we used hexene and hexane. Well, to do this, all we did was we added bromine water, which is Br2 aqueous. We added that to both of these, Br2 aqueous. Okay? Added those in, and then we saw what happened. So what we used, our equipment list, was 4 test tubes. We used aluminium foil. I'll tell you why we use these all in a second. We used a test tube rack. Got to include that. You can use it as part of your risk assessment, maybe. Rack. And our ingredients were basically hexane. Well, in class we use cyclohexane, but on the test we just write hexane because we don't need to know about cyclohexane and all the different structural formulas that we can write hexane in. We use hexene and we use bromine water. Okay, so how we basically set out the prac. We had 4 test tubes, right? So we'll draw them out. 1, 2, 3, and 4, right? Those are our 4 test tubes. Now what we did is we put aluminium foil over 2 of them, just 2, and we wrapped it up just so that no light can get in. Okay, that's the point of the aluminium foil, so no light can penetrate in. This relates to the UV light that we mentioned before. So in half of them, so say these two here, we added, I don't know how to draw those line thingies, but we added hexene. Okay, we added hexene to both of those. Around 2 fingers width, like 2 fingers height, it's about around 2 mils in each. And in these two over here, we added hexane. Alright, same amount, around 2 fingers worth, like that. Now we can't really differentiate between them because they're both colorless, they're both transparent, and they both smell, but they smell pretty much the same. So we can't really differentiate between these. So when you fill them up, make sure you label which one's which, or maybe keep them with different people. Just do something so that you know which one's a hexene and which one's a hexane. Now that we've done that, we put them into that test tube rack. So let's draw one here, maybe. Yep. 1, 2, 3, 4. Now the way I kept track is I did hexene, hexene foil, hexane, hexane foil, in just sort of a logical path, right? Now once we had all those there already set up, we added 10 drops of bromine water to each. Okay, no, it doesn't have to be exact. You can do 9 drops, you can do 11 drops, no one's going to kill you. Alright? But once we added them in, we made sure these ones, the ones with the foil, had no light to them, and we shook them all up. Shake, 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 you know. Not too vigorously, but enough to disturb the fluid quite a bit. Once we did that, we observed the results straight away of the ones that are uncovered. Right, so we had the hexene one, and what we saw after we shook it immediately is we had 2 layers. You could kind of determine between the 2 layers because there's a bit of a little line there, but we noticed that the top one and the bottom one were clear, which is weird because the bromine water we added in up here, these things, they are brown. They are very brown. Okay, they look like dirty, muddy water or some sort of alcohol. So when the hexene, so we'll write H.E for hexene, that'll be a hexene, H.A will be hexane. Okay, the hexene ones were clear on both layers. The foil one we looked at this is the hexene as well, hexene foil. If we looked inside, we also noticed that both of these were clear, even though no light had gotten in. On the other ones, however, after shaking, we noticed that the hexane one, H.A, this one was slightly clear, it was kind of brown, and this one was still brown as hell. It was still bromine water. Same with the foiled hexane one. So hexane, This one was slightly clear. Still brown a bit, but kind of clear. And this one was brown. Okay. Now, I bet you can tell me why, but we'll wait. That was day 1. That was straight after. Day 2, however, had slightly different results. These first two were pretty much the same as they were on day 1. Okay, that was H.E, H.E. These were both clear and clear. Right? Clear. That's an arrow, by the way. This one was clear and this one was clear. Same as before. However, this one over here, the hexane that had been exposed to light, had actually changed. This was clear and this was clear. So it resembled these two now. However, the one that had been covered up by foil even after a day was still brown, or slightly clear at the bottom and brown on top. Two clear, distinct layers. Now, whoops. Now, why is that, you ask? Well, if we go back up here, we know that alkenes will react independent of any energy input. Doesn't matter if you add UV light or not, if you shield it from light or not, they'll still react. The substitution reactions, the alkanes, however, need UV light to react. And when they do, they react quite slowly, which explains what we got down here. The hexane reacted pretty much immediately when we shook it, despite the fact that we had the aluminium foil on or not, that didn't matter. The hexane didn't react instantly, but the one that was exposed to UV light reacted slowly over time. The one that wasn't didn't react at all. Now, what can we draw from this? Basically, our aim was to determine between hexane and hexane, correct? So, we know that the ones we use are the ones with the foil, these two. And what we can say is, how we determine between those is, if we put it in foil, if we put this in foil, and we don't know what this is, say it's X, we know it's either hexane or hexene, we don't know which one. If we put that in foil and leave it for a day after shaking, if it reacts, we know it's an alkene. You know it's an alkene if it reacts. And how do we know it reacts? If it goes colorless, because a chemical change is a change in color, right? If it's an alkane, so in our case hexane, it does not react. No react. Right. And if it doesn't react, we know that we'll see a very distinct brown layer on top and a slightly brown but more clear layer on the bottom. So that is basically the Prac. So to reiterate, addition reactions, alkanes use them. Only alkenes use addition reactions. Why? They have that double carbon bond that's easy to break, and so these bromines, without any help, can break those bonds and add themselves into the molecule. Alkanes use substitution reactions. They don't have that double bond, so the bromines have to break these stronger hydrocarbon bonds. The UV rays from the outside help do that. After some time, the slow reaction occurs and the bromines slot themselves in. And during that reaction, you also produce hydrogen gas, which is where these hydrogens go. So that's basically a rundown on the Prac. If you have any more questions, just ask on the Facebook page and I'll make another video or I'll respond to you personally. Thank you for watching.